there continue to be more fascinating things that I would like to share with you about human and primate morphology. These will now be on the topics of the ossification within organisms, the teeth, and human speech. To begin with, I would like to speak about ossification of the bones. Ossification, the solidifying into bone, generally takes place at a slower rate in human beings than in the anthropoid apes and the monkeys. Looking at the ossification in the human skull, you will be familiar with the fontanelles in infants, the so-called fontanelles, the little fountains. The plate bones in the skull grow and slowly close the fontanelles, and the bones are sutured together. The plate bones, however, continue to grow, and the sutures also continue to grow and remain flexible. The sutures don't ossify in the first years of life, and in fact, they don't ossify fully until the third and fourth decade of life, when they finally do become fixed and rigid. It is quite remarkable that the human cranium remains flexible for so long. This is not the case in other primates, whose plate bones and sutures ossify in the first months and years of life. The further we go down in the primate series, the earlier their craniums tend to ossify as the result of their compressed ontogeny. Ossification also occurs, of course, in the hands and feet, and in the long bones of the arms and legs. Cartilage in the hands and arms, for example, ossify far later in humans than in other primates. In humans, the ossification centers are still absent in the base of the hands and the cartilaginous ends of the long bones in humans, where they are already developing in the anthropoid apes and other primates. In general, the cartilaginous skeleton persists longer in humans than in apes. If we now look further at the ossification of the human skull, it is interesting to see that the bones of the face, the upper jaw or maxilla, and the nasal bones and other bones ossify very quickly compared to the other primates. As we move from the lower catarrhines up to the anthropoid apes and humans, we find that the bones of the face ossify more and more quickly. This rapid ossification of the facial bones in humans means that the development of the muzzle does not take place. In other primates, this ossification doesn't take place as quickly, so the muzzle can develop. In chimpanzees, we see the muzzle develop to a certain extent. In the orangutan and baboon, it develops more. And in other animals, such as the dog, the deer, or the horse, we see the full muzzle develop. In this picture, we see 3 stages of the development of the muzzle in the macaque, an old world monkey. First, we see the juvenile that has a fairly human-like form. Then we see the older, and then finally the adult, where the muzzle has developed very dramatically. The eye socket of the adult is no longer below the cranium, but is now in front of the cranium. So we have seen now that in the human being, the bones of the cranium ossify late, allowing the brain to enlarge, and the bones of the face ossify quickly, holding back the growth of the muzzle. It is just the opposite in other primates, the lower we go in the primate series. These varying growth patterns, this heterochrony, gives to humans and the other primates the particular characteristics that are well known to us in these species. We now come to questions of the teeth. The upper teeth are rooted in the upper jaw or maxilla and the premaxilla. Now, the premaxilla can be seen in monkeys, as we see in this picture. This is a young monkey. Between the maxilla and below the nasal bones, we see the premaxilla, marked number 2. The premaxilla can be found in all mammals, but appears to be missing in humans. Back in the 1800s, this absence of the premaxilla in humans was taken as a sign that human beings are different from the rest of the animal kingdom, and confirmed many people's belief that the human being was a special creation. This struck Goethe as impossible. He was sure that human beings also have a premaxilla. One of his basic conceptions was that what we might call the unity of nature, the fact that all natural forms are related, and in this case that humans and other animals are related and based on the same structural plan, the same organizational plan. So he thought that the human being must have a premaxilla because humans shared all other bones with the mammals. He then began to trace in the skeletons of many, many animals the appearance of the premaxilla as it changed its form from one animal to the next. He finally found the traces of the premaxilla in the fetal forms of human beings. He then wrote a significant treatise on the premaxilla in humans, and was, after some doubt by other biologists, widely recognized as the discoverer of the premaxilla in humans. It's now known that in early phases of embryonic and fetal development, that the maxilla kind of overgrows the premaxilla so that it can't be easily seen. When we now look at the teeth in human beings, we will see their special quality. In the upper jaw, we have the arcade of teeth. And what is noticeable about them is that on the one hand, they are all approximately the same height, with no teeth such as canines standing out. And also, there are no diastemata or gaps between the teeth. The fact that the teeth are all the same size and that they lack diastemata is extremely important for speech. Also important for the development of speech is the fact that the shape of the arcade of teeth in the first dentition is maintained in the anterior part of the mouth in the second dentition, as can be seen in this picture. above the horizontal line, we see that the shape of the milk teeth is retained in the adult, even though the size of some of the individual teeth has changed. If this were not so, acquiring speech would be rendered nearly impossible. The formation of consonants learned by the young child would have to be learned all over again if the shape of the teeth in the front of the mouth drastically changed. Here we see the milk teeth and the adult teeth of the orangutan. The anterior part of the dental arch undergoes notable change related to feeding and defense during the change of teeth. If this kind of change took place in the human mouth, we would have to learn to speak all over again, especially the forming of the consonants would have to be relearned. Let us now spend a few minutes looking at speech itself. We find, very much like we found in the learning to stand up, that human beings learn to speak through imitation, and that this learning process takes effort. The form of communication that we find in animals does not need to be learned. It is instinctual. The adult coyote will still howl, and the lion will still roar, even if they are reared in isolation. But humans do not learn to speak if they do not hear other human beings speaking. Babies at first babble. And in this babbling, they have a kind of universal expression of sounds, with many sounds that will eventually be eliminated from their mother tongue, sounds that might be natural in other languages, such as the clicking sounds of certain African languages. Those sounds are left behind. They are trimmed as the child begins to imitate the speech of those around him or her. We call this the learning of the mother tongue. It's the speech of the mother, father, and others that the child imitates. They learn sounds and words and the grammatical construction of sentences, all through imitation. But again, this process takes individual effort. So we see that for human beings to acquire those uniquely human capacities of upright posture and speech, not only does the formation of the various parts of the body, such as the feet and legs, the teeth and the rest of the mouth, need to be formed in particular ways, but we see also that individual effort is needed.